Welcome to ECEN 160 Lab 4 ALU and multiplexers. The purpose of this lab was to become familiar with the design and operation of common ALU components, design a simple 4-bit ALU, become familiar with some popular MSI devices such as multiplexers, and design a combinational logic circuit. A gospel corollary could be found in Alma 37.6. Now you may suppose that this is foolishness in me, but behold, I say unto you, that by small and simple things are great things brought to pass. If this concept works for God, then it'll work on a circuit. Let's focus on the design and the creation of our 4-bit ALU. This ALU, or arithmetic logic unit, is a circuit that can take two 4-bit numbers, our A inputs and our B inputs, also called nibbles, and they will produce a one nibble output. Using two selector bits, we can choose which function, either adding them together, using the logic function of AND, or XOR to produce the output. Our first step in creating this would be to create a full adder. This is our first building block, or simple thing that we need to create. There are three inputs, A, B, and the carry in, and there's two outputs, the sum bit and the carry out. Let's go make sure, let's pull this up in Logisim and look at it and make sure that we have it correct. We're going to reset our simulation. And we have our truth table over here, so we can see that A, B, and Cn should all be 0, will produce a sum 0 and a carry 0, which is correct. Let's try a couple other ones. A 0, 1, 0 will produce a 1, 0, a sum 1, carry out 0. Let's try a 1, 1, 0, will produce a 0, 1, sum 0, carry 1. Let's try a 1, 1, 1, that will produce a 1, 1. So we can see our full adder is actually working correctly. Our next step is to take that full adder and create a subcircuit using 4 of those to create a 4-bit adder. Let's go back to Logisim, where we can go to that subcircuit and see where we have our 4 bits, our 4 input A's and our 4 input B's. If we add them together, a 1 and a 1 equals a 2. How about a 3 and a 3? That equals 6. How about 15 and 0 equals 15? So we can see that this is also working properly. The next step should be to create one of our logic functions. Let's do our AND. With 4 2-input AND gates, we'll take our 2 nibbles and produce 1 nibble using the AND function. We can do the same thing in Logisim. Go back to our AND, and we can see. Let's try ANDing 1 and 0, or 1 and 1, we'll create a 1. 1 and 0 will be a 0, 0, 1 will be a 0, and a 0, 0 will be a 0. We can try it with all of them, but it will work and give us our 4-bit output of the AND logic. We want to do this 2 more times with our OR logic circuit and our XOR logic circuit. Once we have all of these subcircuits created, we can take them and put them into a 4-bit mux. Add our 4-to-1 multiplexers and involve our 2 selector bits to select which one of these 4 functions will be used when we want to do these 2 inputs. Now let's go to the main. Let's go back to, this is what our 4-bit ALU will look like in our main circuit. Let's go back to Logisim and go to our main and see. Let's pull up, put it, I test the thing, and let's see if we can find out if this works. Let's take a 1001, add it to a 1001, or XOR it. So we can see here which selection options will get us our XOR. That's a 0, 0. We can see a 1001 XORed with a 1001 will give us a 0, 0, 0, 0. So that works correctly. Let's try it with the AND, a 0, 1 selection. That should give us a 1, 0, 0, 1, and it does. Let's try that with our OR, which is a 1, 0 selection bit. And that will give us a 1, 0, 0, 1, which indeed it does. And then we can do the final one of the AND. A 1, 0, 0, 1 and a 1, 0, 0, 1 will give us a 0, 0, 1, 0, which is correct. So there we see we have our 4-bit ALU, and we can select which one of the options we want to use, or which one of the subcircuits we want to use to produce the final output. In conclusion, we can see that something like this ALU may seem really complicated when you first look at it, but by planning ahead and using the simple building blocks of subcircuits, it becomes a simple process. Thank you.